Good evening, everyone. Hope you are having an amazing day throughout with the booths and conferences. Okay, there are a lot of amazing sessions lined up moving further, and one of them is Secure REST APIs 101. So, introducing ourselves, myself, Abhishek Laddha. I am Senior Software Engineer at miniOrange INC and working for around 4 years. I am expertise in working for building security products around WordPress, HubSpot, miniOrange IAM, and I have majorly dedicated my time in building security products around API integration and security.
So, hello, I'm Aditya. So, I've mainly been working on developing IAM software for the Atlassian ecosystem. This mainly includes single sign-on or REST APIs, REST API security, and other IAM-related solutions.
Okay, so the session is all about API security. So we will be covering the following topics. First is API basics, in which we will introduce you to REST and SOAP APIs. Then we will check are REST APIs really secure. Then we will talk about some common threats moving further. Then the remedies for that. And at the last, we will see the popular tools for API security.
Okay, so just to set the context for this session, we'll have a basic introduction to what REST APIs are and how they're generally used in software. So, we talk about an API. Technically, it's just a segment or a part of some software, a small part of some software that we want to embed. So, if let's suppose you're writing some piece of code, and you want some operation to be performed, but that's handled by a third party server somewhere that's hosted somewhere else. If you want to invoke that, you use it. You write it in there. You write that as a REST API. But if you have a look at the architecture, if you have a web app and you want to access something that, or you want to perform some operation that is hosted somewhere else, as in it's directly somewhere else, you will make a REST API call to the server that hosts this piece of code, and that will execute perform whatever operation you want on the data that you send and send back the data to your app. So essentially, the operation that you need to perform, it is decentralized. Instead of having to write it in line in your own code, it can make use of existing softwares. That is the plus point of REST APIs. Typically, REST APIs are called over HTTP requests. That's just basic thinking on also. So APIs typically are, there are two main design strategies for APIs. One of the older ones is SOAP, and the newer one is S. So SOAP, you can read the definition. Or you can read the definition on screen. What SOAP essentially is, it's a protocol. It's a hard-set rigid protocol, and if you have to make calls using a SOAP API, you have to follow a set rigid set of instructions to make those calls, and it only works with XML data. So if you have to make a SOAP call, or if you want to make or call a SOAP API, you will have to first of all put your data into something called a SOAP envelope, and then make sure that it follows all SOAP standards, and only then can you make that request to the SOAP API. And in general, it takes a lot of execution time to process. REST, on the other hand, is actually an architecture style. So you can write any piece of code that you want and invoke it on a mapped URL. That is the basic idea of REST API. So if you have some piece of code that you want to reuse, or you want to make it open to the public, and so that they can invoke your account, whatever data that they want. On top of that, you just map the URL to it, and whoever needs to use it will invoke that URL with the requisite data, and that's basically the REST API. So just have a quick look at the main differences between SOAP APIs and REST APIs. The SOAP, like I said, is just a protocol. REST is an architecture style. SOAP only supports XML-based data exchange. REST has support for everything. It's open. So SOAP is difficult to scale. This is mainly because it's a stateful protocol. When I say stateful, it means that every operation that invokes the SOAP API, the server that is hosting that SOAP API will need to maintain the results of that operation for further processing. So every successive call will need the results of every preceding call. So while this reduces the amount of data that needs to be transferred in each call, it increases memory, it increases overhead on the server side. REST, on the other hand, is stateless, which means all the data that you need to perform that operation is sent over in that request itself, and that's it. It will finish the processing for it and then return a response. So generally, like I said, legacy applications, private APIs, this is mainly because if it's within a closed intranet or closed environment, then this makes more sense. REST APIs in general, if it's a decentralized system, if you're integrating solutions from multiple different platforms, then you use REST.
Okay, so now we have gained enough knowledge about APIs and the REST APIs. Now the question comes is like, are REST APIs by default are secured or not? Let's see. So on the screen, you are seeing some of the major applications in the market: Tesla, Twitter, Optus, Zendesk, Facebook. So they have been heavily attacked in the past due to the vulnerable APIs or the weak APIs, or due to like lack of proper validations of the API. Let's go one by one, each of them. So Tesla, as we all know, like manages the automated cars. So like in that incident, what happens is that their car gets automatically locked due to the broken APIs. So like people face challenges when like they are coming out of their car. So they basically need to use the physical keys to open that door. So that caused lot of trouble among the users, and that like caused lot of reputation damage for Tesla as well. For the Twitter, like as you can see in the data, 355 million users data got leaked. So basically, like hacker exposed Twitter 0-day vulnerability, in which like they basically like got an API in which you just need to submit the email and phone number of the user, and you will be able to get all the data. So Twitter were unknown about that, and all this data got leaked, and hacker like contacted them to pay some huge amount of money. If we next talk about Optus, Optus is one of the leading telecommunication company in Australia, and like they have endpoints in which like they have no proper authentication and validation. Because of that, like a lot of information related to driving license and user's personal email address and everything got leaked. So like Australian government basically like had a call with them, and like there was a severe action against them as well, which basically damages the reputation of the company as well as the users using that. Next comes Zendesk. Zendesk, as you can see in the screen, more than 100K users were impacted. So Zendesk is basically a tool to manage ticketing and all. So they basically like have API which were exposed to SQL injections. So attacker used SQL injection to query the database and able to access all the data. That caused a lot of damage. And lastly, and last but not the least, Facebook. So like as you all use Facebook, and Facebook has a feature called View as Profile, in which like you can view the user's profile and how it will look like from the other account. So in that, Facebook basically uses the access token to access the data of the profile. And like by luck, we can say hacker were able to determine that that particular access token can also be used to access the other user profiles that were even private. So as you can see that 50 million user data got leaked. So this is just a number that Facebook were able to determine. That can be even higher, like we do not know. So like all these incidents are enough to make us sure that we should like have the proper security over the REST APIs, because REST API is a fundamental that we are using nowadays to connect between different applications. And like as we are also using this application, so there is sense of fear among us as well, like our data got leaked, and that's why like we are getting calls from credit card companies and all that, because our data got leaked from these applications.
Okay. So there are actually quite a few threats to open endpoints. So we'll be taking a quick look at some of them. So going by priority, the first one, as you can see, I think you might have heard it quite a few times today during your sessions, is SQL injection. If you, as I said, in a REST API call, you send some data, you send some parameters with your API call, which allows that piece of code to perform its operations. If that data is not properly validated on the API side, then SQL injection can happen if the data that you are sending is directly used in some query. So we'll see a quick demo of this going forward. Broken authentication, again, that's pretty basic. APIs, when you call them, there are many ways to ensure they're authenticated. Either username, password, API tokens, or two-flow. Again, we'll have a look at that. Authorization. So even after you complete authentication, even if you have access to an API, it still does not mean that you have complete access to all the data or all the endpoints. Authentication just gives you or tells the API that you have the right to access it, but it does not define how much of that endpoint or how many of those endpoints you can access or you should be able to access. So authorization is technically defining a scope. So if you don't have this, whether there are admin endpoints, whether there are end user endpoints, everyone will be able to access them if they just have the right credentials. As in, if they have end user level credentials, right credentials, even the admins. Sorry. DDoS attack, again, this is something quite common. If it's an endpoint, it's fairly easy to just set up an attack where you constantly ping some API server. So there are ways that you can defend against this. Again, we'll see that going ahead. Insufficient logging and monitoring. So when it comes to logging, the main point or main plus point or reason you would have logging is if someone is carrying out an attack on your server. The better you're logging, the earlier you figure it out. If there is some message coming, some erroneous set of logs, then you can do something about it. Same for monitoring. If there is a spike if there is a out of the ordinary spike in your access levels, in your usage levels, it sets you off or it alerts you to some attack or something being wrong with that process. Incorrect server security is again pretty basic. It's always, even if it's not a REST API, typically also HTTPS is always secure. So this is some basic point to keep in mind.
Yeah. Now,
so like I said, SQL injection, if you have a look at it, if the endpoint, as you see, is accepting username as a parameter and the execution is directly picking up the parameter and putting it into a query, you can see the issue that might cause. If someone adds a query string next to that parameter, that will get executed when the query is built. So I think Abhishek will show you a quick demo of
Sure.
this. No?
Okay, so we have prepared a node project in which we are going to show you demo of how SQL injection will look like. So as Aditya show, like we are directly passing some SQL query, which isn't 1 equals to 1 means if like you even know the username, like you can directly pass 1 equals to 1, which means true. So basically like the query will accept all the data that should be returned. So as you can see that all the data is getting returned. Okay, but the ideal execution should look like, I just need to pass the username, in this case, Abhishek. So this should be the ideal scenario in which like we only expect a particular username and it should be returned only. Okay, let's have a look at code as well. Just. So as you can see in the code, we are just directly like passing the username that we are receiving rather than doing the sanitization or data input validation. So that is why like user can directly pass the SQL injections and like they are able to retrieve the data that they want. Okay.
Okay. The point of that was to show it's a pretty basic implementation, but the point of that demo is to show that without validation, if you directly just pass anything that you get in a request parameter as a query parameter, you're leaving yourself open to SQL injection or any other sort of attack, but mainly since we're focusing on SQL injection here. Okay. So authentication. So there are endpoints which are generally open to the public, which don't require authentication, which give you some basic information about that service. That's fine. But if you have some API which is working on critical data, which is working on end user data, and you want to ensure that only people who are authenticated or who should have access to it do access it, you enforce an authentication on it. There are multiple ways to enforce authentication in an API. So two main, or one of the two broad strokes are, there are two ways to headers that you can add. So against in any API call for ensuring that it is authenticated or adding authentication to it, you add an authorization header to the request. Against that, if you add basic, the idea of basic is it's basic username and password. So the format will be basic space and username colon password, which is basic64 encoded. This is the absolute again basic form of authentication, username password based. Second would be bearer token. Now here the token can be an API key, can be an auth2 token. It depends on which way you would want to go. But you use the bearer header, the bearer key when you're trying to authenticate your API call via some sort of token. So there are two types of tokens. One is API keys. So API keys are typically maintained by the service and assigned to the service or the user who's trying to call that endpoint when they log in. Auth tokens are generated from the auth flow. I'll explain that in the next slide. So basically, I'm not sure how many of you are familiar with auth. It's an authentication protocol and it works on the basis of tokens. So you can, instead of just the hard code or the limited set of tokens that API keys provides, you can generate tokens dynamically using an auth provider and authenticate your API call with those tokens. So we've covered authentication. For authorization, Auth 2.0 is the best way to go forward because it allows us to define scope of someone's access. If someone logs in with their user credentials based on the groups assigned to them or the roles assigned to them, you can define what all content they can access. So authorization is technically limiting the access of admin level APIs or critical APIs to admin level people, so that end users also cannot access it with their regular credentials, even though they authenticate themselves. So the Auth 2 typically works with two types of tokens, which is access token and refresh token. Here, the main token that you use to authenticate your APIs is the access token. If you have a look at the diagram, the client there is my web application. So I will first need to retrieve a token from the authorization server. Here, the authorization server will be an Auth 2 provider. You first log into your authorization server. It will provide you with a token. That you use that token in your REST API against in the authorization header against a bearer key, and the resource server will then validate that token. That's the basic flow where how Auth 2 tokens can be used to authenticate and authorize an API call.
Yeah,
We'll have a quick demo of authentication. Vulnerable APIs regarding authentication and authorization.
Okay, for the authentication, you can consider the same case in which we are not passing any headers. We are directly passing the correct username and it is showing the result. There is no validation that this user is mine, so give me the data. There's no validation. And for the authorization, what will happen is that first will be generate the token as Aditya mentioned. So let's do that. Okay, in which I am passing the username and password of my user, if you can see here. Okay, and I'm able to retrieve a token. This token basically consists of the user information and the roles it has. So accordingly, it should be allowed to access the resource based on the roles. But in a scenario, we will see that user is able to access both the user endpoint as well as the admin endpoint, even though that user credentials are for user credentials, like a normal user. Let's pass the token. And as you can see that we are able to retrieve the information. Okay, I think I am logged in as an admin. Okay, let's try with the user, normal user. Okay, let's have a new token here.
Next.
Okay, so as you can see that the information is coming out of a normal user. Let's try to access the endpoint that should be meant for admin. Okay. So I'm even able to access the admin data, though I'm not the right user to access that. So this is where the authorization flow comes into the picture, so that like even a user does not have any valid scopes or permission can still able to access the data. So like you can consider example like if there is an organization in which there is an admin and you are a student, you are able to like update your marks by having the token of your own token, updating your own marks. So you can consider like how much flow it is there. Okay, yeah. Okay, one more attack I will explain to you, which is access attack. Okay, so in that attack, basically like someone will pass a script that will be executed when a response is returned. So let's try an example to hit that in a browser. So as you can see that like using JS, this is just a basic example, but using JS, someone can like manipulate the user cookies and all by just passing the JS. So there is no proper like validation when we are doing the response on the browser. So that's where like the access attacks come into the picture.
Okay, so the access attack part also comes under input validation. So it's one of the vulnerabilities which you will face if you don't have a look at the parameters that you're receiving in the API call. So I think we'll have a look at some practices, basic practices that you can do ensure from your side while you're calling an API and while you're writing an API to ensure that it's a secure API. Right. So REST APIs, the whole point of it being stateless, is that everything that that service will need to execute, its whatever assigned role, all of that data is sent in one call. So all of that data is, if you send, when you make the REST API call, that all of the data is open to the world. Anyone can intercept it and they'll have all the query parameters that you want, username. Even after adding that authentication token, they might not get authenticated, but since that authorization header is open to the world, they will be able to get your token and then make other calls with that token. So simple way to prevent all of this, all the data that you send in a REST call, you encrypt it. You can use any encryption algorithm, RSA, etc. And you can encrypt that data from your side while you're sending it. And again, when you're writing an API, it has to support it anyway. So the API needs to support encrypted data, but that's the whole thing. Both of them should be, that's how you make it secure, the whole process. Like we saw before, data validation and sanitization, input validation, all the parameters that you receive, even after decrypting it, that still can be some sort of malicious bit of malicious code, or it can be a SQL string. So even after you decrypt it, you still need to perform some sort of data validation to ensure that the format or the type of data that your API is expecting, that is exactly what you receive and not some sort of malicious string. Again, authentication, authorization, quite basic in order to ensure that only the people who can access it should access it. You have authentication and authorization on top of that to restrict it even further and set scopes for who can access what. API tokens. So most services out there which provide which provide endpoints for their bits of code have a system of managing tokens from their side, API tokens. When you log into their platform, when you log into their service, they will assign you a token. Now, this token is again plain text string when they give it to you. So it is up to you and up to the service itself on how it manages those tokens. Storing it in plain text is always an issue. It's always going to be an issue. So again, encryption comes into play here. You can simply compare hashes. You hash the string and you send a hash token in your request, and both hashes can be compared. So API token management. Rate limiting and throttling is more about restricting the number of calls or restricting the number of times you can hit that endpoint. Rate limiting is on the app side, on your client side. You basically define or you basically set the number of calls that your app can make to the service. And you can, another aspect of rate limiting is managing the amount of data that you're sending. So instead of sending
one API call with a large amount of data, you can spread it out evenly across 2 or 3 calls so that the service, there's no excess load on the service while executing that piece of code. Throttling is on the other side. The service will implement throttling, and this is a little, it's brutal basically. So the service, the service hosting the API will restrict the number of calls, doesn't matter who's making the call, will restrict the number of calls to some X per hour. So if the X is exceeded, the service will refuse any further requests, doesn't matter from who it's from. So both of these together in conjunction will allow seamless processing. Because if you just have throttling, there'll be n number of services around the world which will go down, because once the service reaches its X amount, then no input, no request will be entertained. So if the app itself can sort of take care of how frequently the endpoint is being called and how frequently it needs to call it, then there is no scope for the service being down. Logging and monitoring, like I had mentioned, is important. Monitoring, again, because it gives you a real-time view of your service, the load that it is under, the number of requests it is having to handle. And once you figure out that something is going wrong, in order to figure out where it is going wrong and because of which endpoint, you need logging. So logging, if you do it properly, when an issue occurs, if it occurs, then the quickest way to resolving it is to trace your logs. If your logging is proper, you can identify which service or which endpoint is being misused and handle it accordingly.
So in the last demo, we have seen the cases of vulnerable APIs through various kind of attacks like XSS, SQL, lack of authentication, and proper authorization. So let's go one by one how the fixed API should look like, and we will also go through the code what we have made the changes such that it makes its word correctly. Okay. Okay, so like straightforward, like we should expect a proper username, then only it should return the result. But let's say if I pass the SQL, okay, let's copy it from there.
That's important.
Okay, it will not give you a result because like this is the username that is not present in the database. So it is directly matching now with the username rather than the query. So let's go through the code. Okay. So as you have seen earlier, we are directly passing the username as a query here, instead of like passing as a parameter. But in this particular code, which is a fixed code, as you can see, we are basically doing a query again, which will sanitize and validate the input and will remove any malicious code that we are passing. So that's why it is going to give the correct result, because now we are taking username as and value rather than as a query part. So this is how like the correct code will look like. Okay, next term is the access attack. So in this case, I'm still passing the same script, but as you can see that now, like when we are doing the response, we are basically like encoding them and doing the proper validation before we are sending that to API response. So as you can see that now we are not going to see the script. It is just like the tags that have been encoded and decoded. Okay. The next term is authentication. So in the authentication, basically like we will required to first generate a token, then only we are allowed to access the API. So let's see that as well. Okay, so this is the login API for that. Okay, so this is the protected endpoint. Let's try to access that. So as like my token was not valid, like it was previously stored, so that is why it is not giving me the access. So this is where the authentication comes into the picture. Now we are requiring the identity to be proved, then only like access will be given for the protected resource. So let's try to pass the valid token now. So now as you can see in the message, the endpoint can be accessed successfully now because we are validating our identity. Now let's talk about the authorization. In the authorization, I'm again going to generate a token for the user, as you can see in the request. This is for the normal user. So now like when we are trying to access the user endpoint, it should work as like it was working previously. But when we are going to access the admin endpoint, it will give me an error that you are not allowed to access this resource. Here we go. But let's now generate the token of admin. Now try to access the admin endpoint. So I'm able to access the admin data. So if we see the code, we have now added a proper layer of authorization as a middleware. Okay, so this is the code for fixed authorization. Okay. Now, as you can see in this particular endpoint code, now there is a check for role. As this endpoint is basically meant to be accessed by admins only, so we have added a check in the code to make sure that only admin can access that. If you are not an admin, so an N401 unauthorized access response will be returned. This as simple as that. Okay. Apart from that, like Aditya mentioned about some cases of rate limiting and all. So basically, like there might be cases like although you implemented a proper security, but some bad actors will basically try to attack continuously on your endpoints and will make sure that no one can access, no one other people who are the good actors can access that. So this is where like I have made a simple example in which I have like implemented the IP whitelisting, in which like we are expecting that like we will only accept the request if that is coming from the certain sets of IP. So you can consider the case like for the Marigold, we only want to allow access if like this resource is accessed from the Marigold environment, not from like outside world. So we have added some kind of checks like only these should be the IPs, then only like the data will be returned as a response. Okay, so like I do not have the current IPs that are in the list. So if I try to access an endpoint, I will get an error response. Access denied. But if I have that particular IP, I will be able to access that data properly. So that's where like you can implement the rate limiting to make sure that like no other outsider can be easily access your endpoints. Okay, so we have now seen enough knowledge about like how to write good code for making sure that your API is validated, authenticated, and like having the proper authorizations, and like it is also prevented from rate limiting and all. But there are like no one likes to write the complete code. So many big organization basically does is that they like buy some ready to use product that can directly be integrated with their application that can do all this stuff rather than like they need to worry about that, and then in that time they can do other stuff that are required for their organizations. So this is a list of the popular tools that are like used for API authentication, protection, and security. So one is the web application firewall, API gateway, API token management tools, logging and monitoring tools. So like the WAF and API gateway are similar. If we talk about the APIs, like they both sit on the network layer between your client application and the API resource. So like whatever request you are going to pass to the endpoint, you need to basically like pass it through WAF or API gateway, and then based on some filters or rules, whatever rules you want to implement on top of that, then only your request will be proceed. Okay. So the API gateway basically has an advantage of like providing out of the box authentication, authorization, and can also provide stuff like rate limiting, monitoring, and everything like IP-based restrictions. So that's where like API gateway is in major use. And in the next slide, we will talk about that in detail. Okay. The next one is API token management tools. As Aditya mentioned, like you do not want to have your own identities and instead rely on some other providers like Okta or Zero or even miniOrange to make sure that they are doing the authentication part, providing us with the tokens and revoking and rotating the tokens as well. So in that case, we can use the token management tools other than writing our own code to like do the validation from resource server and all. The last comes is logging and monitoring tools. in which like we have some popular tools available in the market called as New Relic, which will directly help you to like track every logs of your request that is coming on your endpoints, and it will basically like show a complete analytics. So let's say like if someone attacked your endpoints, so it will be easy for you in the future to track it down, like how attack was made and like from what IP that attack was made. So it will be easy to block that IP and like do the further remedies. I have focused majorly on the API gateway architecture. As I mentioned, like API gateway sits in between the client and the REST API services. So like instead of writing the code of like implementing authentication, authorization and all that on your code level, you can you directly use a API gateway that will do all the stuff. So like in the API gateway, what happens is that whenever request is made from any client application, so that will basically directly be going to the API gateway from the network level, and API gateway is the boss here. He will track all the things, and based on the filters that you are going to apply on the authentication layer of API gateway, then only you are able to access the data. So like we can implement authentication, caching, rate limiting, monitoring. So there are lots of feature available on the API gateway. The popular API gateway tools are APG. miniOrange has its own API gateway as well called Secure API, which is like yet to be made to the next level, but it is still like of a great use to a lot of customers.
Right.
Okay, so from the session, I think we are going to say no to the vulnerable APIs and secured APIs. That is something we are going to implement moving forward.
So just to sum up what you might have learned from these few slides, we started off with the basic architecture or basics of what an API is, then bifurcated into the types of APIs. Though SOAP might not be popular right now, but it was at one point in time one of the standards for building APIs. Then the common or typical threats to APIs, and this is from both sides, while you're calling an endpoint and while you're writing an API as well. Again, best practices to ensure that your REST APIs are secure, and also that you call, or while you're making a call, your data that you're sending in that endpoint needs to be secure. So we had a look at how to do that. Then Abhishek ran through a few tools that we can use to ensure that there's no misuse of the endpoints that you provided, and if there is misuse, how to track down and fix those issues.
That's
So this is some basic info. These are some sites which you can go through for some basic information, learn a basic level information for APIs and also for API security, right? Any questions, anyone? Yep.
the what would be the best way to mitigate the DDoS attack while protecting REST APIs?
So like we demonstrated, rate limiting and throttling, it restricts the number of calls that you can make and the number of calls that the service can receive. So DDoS by definition is a continuous set of attacks, continuous pings to a service or to an endpoint, and which is what blocks that endpoint. It basically utilizes all the resources that that API or that service does have. From memory point of view, from computation point of view, it blocks everything on the service side. So to restrict that, you restrict the number of endpoint calls. On the service side, you do it with throttling. On the app side, you do it with rate limiting.
Okay. But before that, by using a novel fish, we expected the ending towards him. Like physical implementation blocks the.
So there's two different topics there. One is authentication, one is authorization. So the reason he was able to access admin data using the same token is the authorization level check wasn't implemented in the code. Auth supports both auth as a flaw, OpenID as auth as a protocol, and OpenID as a protocol support scopes. But within the code, we had not implemented it. That is what made it vulnerable. So with just that token, which is authentication, which is basic authentication, you can access all data since that scope check is in there. The scope is what defines the authorization part of it, which is why using the end user token, he was also able to access the admin data.
Sure. So it's I want to like develop any GRP.
Yes.
Who want to design like the one to take access to module users and files could access the rest of the.
Right.
So this kind of authorization can be developed in mix of like this attack on this.
Okay, so in that, like if you're using some tools like API gateway, so for each endpoint you can determine like which user should be allowed to access or for which roles. So there is one condition, and in the code implementation you can also implement the role-based checks as I show in the example. So like for each endpoint there will be separate code, and for under that code you can explicitly mention like which roles are allowed to access that endpoint. Then only like they will be able to access, else an error will be thrown. So both ways we can handle that.
Yes.
Anyone else? Yep.
It was it tells the system with us, and it has not all the SDK and integrated. And that's in the other in there's no voice person. We could have an recommendation for what the tool is to use, like also it's something that what other tools which that or experience that of experience for them when you guys suggest to do all this find out lot
So are you referring to the API implementation? How to figure out flaws in API implementation?
implementation as well as when the system is brought to you.
Okay.
Implemented a lot of the elements. So how do you upload it? What is like flaws of also of the implementation how the rest of it what's supposed to be
For that, like there are some automated tools available that can basically like ping your request with some set of rules that are not allowed to access the endpoints. If like your endpoint is returning 200 and the data, it means that there is a flow. That is sort of automation that you can make in order to ensure that there are a lot of APIs. So you cannot like manually hit that each API. So you can do the automation using some tools. So it depends on like which framework you are using for REST APIs. Accordingly, there are tools available.
So you saw the window that he had, right, for the endpoints. It's called Postman. So you can write scripts in that to automate DDoS attacks, to replicate DDoS attacks, to replicate unauthorized access, and use that to test your endpoints.
So is the pen testing only way to avoid and mitigate this thing?
So all the points that I described, they were both from the end user, as in who calls the API, versus and also for people who are implementing the API. So while implementation, if you ensure that there is a sufficient authorization in your access itself, as soon as the endpoint is hit, control comes to that service. As soon as code execution enters that service, first thing you check is it authenticated? Does it have that token? If it has that token, what is the scope that it can do? So all of this is done on the implementation level within the service itself. After that, you can check the parameters for input validation. All of that, if you handle within the implementation itself, it considerably reduces your exposure to attacks.
Apart from, yeah, pretty.
I was just going to say that while calling the endpoint also, then if you're ensuring that your data is encrypted, then again from both sides you're ensuring that everything is safe.
Yeah. So in a simple shopping cart application, like we add some items, and got time when submitting we don't change or encrypt the value. So a lot of typing postman or interceptor like returning.
So that's a vulnerability. Because you don't want anyone to intercept that call and know that you're shopping for this, or this is the amount that you're shopping for, that's the price of it. So that's a vulnerability, and this needs to be handled on that shopping site side. So that whenever you click on submit, an API call goes to whatever database they have. So the data in transit should be encrypted. So this should be handled on the shopping cart side.
And if you do not want to have the headaches of like testing it out, writing the codes, then like you can also use WAF and API gateway in combination. So WAF can prevent you with the SQL injections and all. So that's one part is sorted. No need to write any code, just rules. Then API gateway will basically like add some filters on top of that for authentication authorizations. And like
or bureaus for it?
For SQL injections and all that as well. Yeah, you can like add some checks there. Like if that particular thing is for access attack or like SQL attack, web will ignore that and block that. So both can be used in combination. And API gateway tools are like too much advanced now. So you will also see the analytics, like how much requests have been processed, if that endpoint is loose or not. You will see all the details. Then you like will have a report and will determine like which things need to be fixed and like which not. Anyone else?